Now we're going to learn about the volume of a cylinder. And I can assure you it is much more easier than the surface area of a cylinder. So let's get right to it. So the volume formula is pi r squared times h. Doesn't pi r squared look very familiar? Because it is the formula of a circle. And if you just times that by h, that's the height. So just the height of that. Let me give you a real life example. So we have a coin. A coin's pretty flat, it's like two-dimensional. And if you want to find the area of this, all you got to do is A equals pi r squared. That is the area of a coin. But if I keep stacking on coins, eventually it will look like a 3D object. Like if I stack 5 of these coins, like it's getting some height, it's turning 3D. So what you can do to find the volume of this is you can just do, so volume equals to A times H, and A just means area. So V equals to pi r squared, because we know the area of a circle is pi r squared, times H. So in this scenario, we have 1, 2, 3, 4, 5. We have 5 coins. So what you can do is you can just find the area of one coin and times it by 5. And that will find you the area or volume of these 5 coins. So in this scenario, we can just do pi squared times 5. That is the volume of 5 coins. So that is why the formula for the cylinder is just going to be pi r squared times 8. So this is of a circle, and just h is just how many coins it's stacked up by, pretty much. So now let's actually do some questions. Okay, so we're asked to find the volume of this cylindrical shape. So what is the volume formula? So it's going to be pi r squared times h. Perfect. So what is the radius and height in this shape? So we know that the radius is 4, so r equals 4. And height equals 10. So the easiest part, all you got to do is just put in these values into the formula. So V equals 2 pi times 4 squared times 10. And all you got to do now is put that in your calculator. So pi times 4 squared times 10. That gives us an answer of 502.654 and So let's just put that two decimal places. So 502.65. And never forget, if you do volume, always remember unit cubed. The reason why it is, or an easy way to remember if it's a squared or a cube, is if you're doing a 3D object, 3D, you will have something, so let's say x cubed. If you're doing a 2D object, you'll have x squared. That is just a quick way of remembering. So if you're doing 3D, it's always unit cubed, 2D, unit squared. So that's really easy. Let's just move on to a slightly more difficult question. So let's find the volume of this cylinder. So I think from the previous example, we now know that the formula for a volume is pi r squared h. Okay, so let's do it again. So thing is, yes, it looks the exact same, but there's just one little catch to it. Instead of the radius, we're actually given the diameter. Diameter means from one opposite point of circle to the other. We want radius. So how do we get the radius from 30 millimeters? Radius basically means from the center to a point on a circle. So what you can do is, radius is half diameter. So if you are given a diameter, all you got to do is divide by 2. So we're going to do that. So 30 divided by 2 is 15. So now we're just going to say that the radius is 15. So r equals 15, h equals 24. Now it is the exact same thing as the previous example. So all we're going to do is just put in these values. So pi times 15 squared times 24. And if you put that in your calculator, you will get pi times 15 squared, 16,964. It's quite a long number, 16,964.600. So that's just going to be 60 millimeter cube. That is it. Now let's move on to a difficult question where you have to find the area of the volume of 2 cylinders. So now we're going to find out how to find the volume of a hollow cylinder. So what does a hollow cylinder actually mean? It basically means that you have a big cylinder, as you can see here, and then a small cylinder has been taken out of it. When we were doing 2D shapes, so area of a composite shape, let's say I had a bar of chocolate. And then I took a bite out of it. So let me just take a little bit out and draw like this. I took a little bite out of it. Would the area of this shape get bigger or smaller? It will get smaller because since I'm taking a piece out, the area would be less. The same concept applies for 3D objects as well. So we have a toilet paper roll here. There is a big cylinder, so this big one here, and a little cylinder has been taken out of it. So this small cylinder piece has been taken out of the big cylinder. So how do I calculate what's left, the volume of what's left? Just like composite shapes, it would be area of big shape minus the area of the small shape, and you get area of what's left. Area left. So that was for 2D shapes. But for 3D shapes, it's going to be volume of big cylinder. So we're going to find the volume of the big cylinder, find the volume of the small cylinder, minus that, and you'd get the volume of what's left. So let's actually do a problem so you have a better idea of what I mean. We are asked to find the volume of this hollow cylinder. And it looks quite confusing, but don't worry, we're going to do this together and hopefully it should make sense. So what the formula was the volume of the big cylinder minus the volume of the small cylinder. So let's call the volume of the big cylinder V1, volume 1. So we look at the outer circle, and you can see that from this point to this point, the radius is 4, height is 12. So the volume for the big cylinder is going to be pi times 4 squared times 12, which is equal to 603.19, and I'm just going to say 2 dp for 2 decimal points. Yep. So that is the volume for the big cylinder. So now let's find the volume of the small cylinder. Let's find the volume of that hole. So we're going to say V2 is equal to, and we know that the radius is from this point to this point for the small cylinder. So it's going to be pi times 2 times 12. That is equal to, if you just put that in your calculator, 150.80 2 dp. So now we have the volume for both the big cylinder and the small cylinder. All we got to do is to minus them to find the volume of what's left. So to find the shape, this actual shape. So you can just say V equals to V1 minus V2. So that is volume 1, which is the big cylinder, minus volume 2, which is the small cylinder, which is going to be 603.19 minus 150.8, which is equal to 452.39 centimeter cubed. So that's basically it. All you got to do is, just like composite shapes, you find the volume of the bigger shape, which we did here, find the volume of the smaller shape, or how much you took out, or the bite, however you want to say it, which is this one, and then to see what is left, to see how much volume you have after you've taken out a little bit, all you got to do is just bigger volume minus the small volume, and you will get the volume of what is left. So that is one of the harder questions. Now let's move on to a worded question. Now we have a worded problem, and quite a tricky one as well. Tom is planning to build a cylindrical water tank to store rainwater for his garden. If the tank should have a capacity of 500 liters, he wants it to be 2 meters tall, what would the radius be of the cylindrical tank? See, already, this question is quite weird. We're not asked to find the volume. We're actually asked to find the radius. We're actually already given the volume, matter of fact. We know that the volume is 500 liters and the height is 2 meters. So what I have done here is I have just drew a cylinder and written down the information we are given. So we know that V, volume, is 500 liters and the height is 2, so I'm just write 2 here. What would be the radius? See, now we're stuck at another problem. How can we have liters and meters? Those two are two completely different units. Like, I can't do kilos and meters. They're just not related at all. But luckily, you should remember this conversion. 1 cubic meter, so 1 cubic meter means 1 meter cubed, equals to 1,000 liters. Using that info, we can convert the 500 liters into meters. So then we have all the units into meters, and then we can actually start doing the question. So if 1,000 liters makes 1 cubic meter, half of 1,000 is 500. So if half 1,000 is 500, then half of 1 would be 0.5. So 500 liters is equal to 0.5 meter cubed. Now that we have converted that liter into meters, let's write everything we have right now. So we now know that the volume is pi r squared times h. So let's just put all this information we have in an equation. So 500 liters was the volume, which we can also write as 0.5 meter cubed, because we found that out from the conversion, equals to pi times radius squared. We want to find the radius and we don't know it, so it's going to be left as r, times, what's the height? We are also given the height. It says 2 meters tall, so 2. So this is the information we have now. 0.5 meter cubed is equal to pi times r squared times 2. So now, in order to find r, what we have to do is, we have to put this pi on this side and this 2 on this side. Meaning, if we want to find the value of r, everything must go on the other side of the equal sign, and r must be left alone. That sounds confusing, but we're going to do it together. So how do I find r? like I said, we have to move all this stuff. So we have to move the pi and the 2 on the other side and just keep r alone. So I'll give you a quick example. X plus 5 equals 8. How would you do that? What you're going to do is make this x alone. So x is going to be here and everything else is going to be on the other side. So in your head, you're going to be like, oh, x is equal to 3. How do you know that? So what you did in your head was you're going to minus 5 on this side, minus 5 on this side. So the plus 5 and minus 5 cancel out. So you always do the opposite operation. So if you have plus, you do minus. If you have minus, you do plus. If you have division, you do timesing. If you have timesing, you do division. So you always do the opposite operation. So the plus 5 and the minus 5 cancel out. And then you do 8 minus 5, which is x is equal to this is what you did in your head and you didn't even realize it. See, maths is like a weighing scale. If I do something on one side of the equal sign, I have to do the other thing. Everything must be balanced. If I minus 5 on the left hand side of the equal sign, I must do the same on the right hand. If I do it here and not here, then my maths equation and everything just goes wrong. So that is what you have to do for the same thing for this equation. So we have 0.5 equals to pi r squared times 2. Let's get rid of that. Let's get rid of pi first. So you can clearly see that this r and pi have a times relationship. So like I said, you have to do the opposite operation. And what is the opposite operation of times? Divide. So let's divide pi on both sides. So because of that, pi, so times pi and divide by pi, they get cancelled out. And what we have left here is this. 0.5 divided by pi equals r squared times 2. That is what we have left. Now we're going to do the exact same thing for the 2. Just like pi, 2 has a times relationship with r squared. So what we're going to do again is we're going to just divide by 2 here, divide by 2 here. Like I said, weighing scale, if you do it on the right hand side of the equal sign, you have to do the same thing on the left hand side. So what we now have is 0.5 divided by pi divided by 2 equals r squared. So we're nearly there. So let's just put this in the calculator. So if you put 0.5 divided by pi divided by 2, you will get 0.07957747155. It's quite a long number. So let's just simplify that to 2 decimal places. So we get 0.08. That is equal to r squared. We're so close. We just have one more thing to do. We want to get rid of this square from the r. So what is the opposite of squaring a number? Square rooting a number. So we can say that if we square root r squared, that will equal to r. Because just like the weighing scale, if you do the opposite operation, so this square root and this square will get rid of each other and you'll just be left with r. So let's do that. So 0.08 square rooted equals to the square root of r squared. And we know that if we square root r squared, you'll just be left with r. So r is equal to, and if you just chuck in 0.08 in your calculator, you will get a number of 0.2828427.125. but we're just going to put that into 2 decimal places, so we're going to leave it as 0.28. We are now done the question. So now your answer is, the radius is going to be 0.28 meters. My bad. So this is one of the harder questions, or potentially the hardest question you will encounter in this topic. It requires you to think of the conversions you learned previously. How do I convert from liters to meters cubed, or meters cubed to liters? And also understand that we were not asked to find the volume, but we're asked to find the radius. So you had to manipulate, you had to change this equation. So you had to move this pi to the other side, move this times 2 to the other side. So you had to use also algebraic techniques. So what you do, this is called algebra, just moving all these variables and everything from one side to another. So you have to do that as well, just to find r, and then also understand that we have to do the opposite operation. So for timesing, dividing, for squaring, square rooting. So all of this just to find the radius. So if you find this question easy, or if you understood what I did here and you can clearly do it again, you will have absolutely no problem whatsoever with this topic. You will in fact find it quite easy. So yeah, that concludes volume of a cylinder. If you have any questions, feel free to email me. And yeah, thanks for watching.